Hello. I'm bored today. I want to throw on some music. I just realized I didn't have anything ready. Hopefully, it's probably gonna be more of the same. Let me see. Let me just put on some. Let's just fucking put on the mic and auto. Whatever. What's the worst that can happen? It's like legal. I'm allowed to do that. So today, obviously, our goal today is to do some studying, some very good studying. Um, a couple of things are different. So this is obviously the second time we're doing this, right? So things are a little different this time. The main primary difference is I didn't like the application that we used last time. I wasn't a huge fan of it. So in response, let me see, it's this scene, right? Yeah. And then we're gonna get rid of what's that one? Oh yeah, we don't like that one. So last time we studied, we did Calc 1 and Calc 2, a lot of that. This time we're gonna be doing a lot of Calc 3. We're gonna go back to some Calc 3 stuff. Really, it's just like the early shit, linear and vector arithmetic, pretty much. But instead of using, you can kind of see what's going on here at the top. Instead of every time I get distracted, I put $5 in that Slate website, which I learned that returns nothing. So I literally am wasting money, which wasn't the goal. The goal was to like just throw money somewhere. Hey, no problem. Nice to have you here, Unstucky. The difference is I literally just looked for the least, like the worst performing stock of 2026. No idea if it's true or not. It looks like it's not doing so hot right now, year to date. I'm just gonna throw 20 bucks at that every time I get distracted, and I'll just like I'll pop in and look at the chat every once in a while, and if anyone's asking any questions or we're talking about stuff, we'll go from there. Appreciate it. I'm literally just here trying to get ready for my finals. So with that all out of the way, I'm literally just gonna start hitting it. Yeah, not much to say. You guys might not hear me too much because my mic's in the opposite direction. But I'm gonna do my best to kind of mitigate that this time around. So, welcome. Let's go back into. I'm gonna be doing it based off of the homework that we have. Let's see. All right, we're hopping into. We did some dot product already. Let's do some more for review. See, we're on question 131. Let's do 132. Scroll down. 132. So the following exercises in two-dimensional vectors A and B are given. Find the measure of the angle theta between A and B. It's been a minute. It's been a minute. I have something here written down saying that the dot product of two vectors is equal to the magnitudes of those vectors multiplied by the cosine of theta. So I'm assuming we're going to use that. Let's just write down what we have. We have A equals 2, 1. B is equal to -1, 3. And then we know that A dot B, we know the dot product is just the sum of their components multiplied together, right? So like 2 times -1 is -2, plus 3 is -1. If I'm remembering how to do that correctly. And then the magnitude of A is the root of the square of the component squared, or of the sum of the components squared. It's the distance formula. So 4 plus 1 is 5, root 5. Right? Yeah. Yeah. And then magnitude of B is 10. And then cosine of theta. Ah, I see. So we take that previous formula, that u dot v. I wish I could like write what I'm writing on the screen. That's got to be something I start doing, like some sort of like, obviously it wouldn't be paint.net, but like some sort of way of streaming kind of like the questions on this end, and then being like, okay, this is what I'm doing, guys. Da 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 da. I mean, maybe we can do that next time. It's a concept, but does that count as a distraction? Nah, because it's still about what we're doing. So we see the dot product over the product of the magnitudes. Let's see. Dot product is -1. So we have -1 over root 5 times root 10. Man, I've taken like a week break and it's like completely stunted my brain. I should have done like a better warm up for this. For 5 or 10. That's just root 5 times root 10, right? I mean, obviously that, but actually, if I do it in my head. No, that doesn't work. Does it? Actually, I think it does. Yeah, it does. Okay, so we can do that. So it's root 50. We can divide that by root 25 and root 2, so it should be 5 root 2. Which means then we just multiply the top and the bottom by root 2, and we get root 2 over 5. So negative root 2 over 5 should be the cosine. I'm gonna do this off screen to not trigger anyone's jams. And then express the answer in radians rounded to 2 decimal places. We have to use a calculator for that. I mean, I'm pretty sure we don't have to, but we're going to. So we said it was negative. Let me bring this back up. Said it was probably a better way to do this. Oh, no, we said root 2. We said root 2. Root 2 negative divided by 5 is this. Then we take the anti-cosine. Or the arc cosine. We get this in degrees. We want it in radians. Well, we have the degrees. I can tell you right now that it's... I can tell you right now that it's not acute. So we know it's not acute. We want it in radians. So we're gonna take this number, and we're going to switch this to radians, and then we're gonna do the arc cosine again. And we got 1.8 radians. But he wants it in 2 decimal points. So we're gonna do theta is equal to roughly 1.86 rad, not acute, right? Because if it's going to be acute, it needs to be less than 90. So let's see if I had the right answer. I think the solutions are somewhere in here. Oh, but it's an even one, so I don't think we get the answers. How lame. I'm not looking at the next one. I'm just looking at the one we're doing, but it's not on here. Let's do, fuck it. Let's just chug it into one. Okay, looks good. Just checking on it. You can never check too many times. What is this? Is it playing twice? Mute that shit. What the fuck? We don't want it playing twice. Alright. 1.43 ratings. Did I do my math wrong? Some aspect of this wasn't negative that I thought was. Ah, I see what my mistake was. I swapped the signs, but it's still gave us the not a cute response. Or actually, it is a cute. Must be less than 1.57 radians. So I was wrong. Because we had the wrong dot product. The dot product should have been 1, not -1. To be fair, I didn't write the whole thing down. I just kind of skipped to it and did it in my head. So I kind of did it. So we should have root 2 over 5. Let's see if the calculations add. Right, so 2 rooted divided by 5. That, and then we want to take the... we have 1.28. And then we're going to multiply this by 180 to see if it's a cube, because I don't know how to do it in radians. Obviously, I just said how to do it, but I did not know that. We're supposed to multiply by 180? Did I have that right? $1.28. I think we... if I have it in ratings... no. What do we want to do? We want to... trying to remember how to do this. So if something is 180 degrees per pi radians, is pi radians over 180 degrees. Yeah, I want to multiply it by 180, then divide by pi. Ah, and that's a cube, because it's less than 90. Okay, so I figured it out. I was thinking about it. I had to think about it for a second. I had to think about the conversion factor and then add it in. So then, yeah. If that's going to be 1.28 radians, that will be a cube. All right. So warm up session, right? Warm up. Let's do 134. Let's just skip to the next even one. So we have u equal to 5i and vi. So we're going to convert this to standard. So we're doing I hat, j hat, k hat, etc. We're doing, and feel free to do these with me if you have any clue what we're doing. V is equal to -6. We're going to do uv is equal to... I wish I could do this on screen. I need to invest in that. Something to do that with me. Me fucking... Mozart going... or Beethoven going ham over here. Can't believe this Mozart is crazy. Beethoven, fucking killing it. He's giving me anxiety over here. And let it autoplay. It'll play something cool. It'll always do something fun. I'm just getting into classical music, by the way. So I'm gonna get the artists confused occasionally. All right, 134. So the dot product of this one is gonna be 5, and then no, it's gonna be since they square, they're what's the word? It's gonna be 5 times square root of 72. Can we consolidate that anymore? 72, take a 2, take a 2. We can take at least 36 out, we know that for sure. 36 times 2. We can say 6 times root 2. And 6 times root 2 times 5, which is 30 root 2. God, I hope I have that right. Oh, no, we're not multiplying them together. We're adding them together. So 5 plus... Is that right? I'm doing something totally wrong. I think I noticed what I'm doing wrong. Yeah, I noticed it. Okay, so negative 30. Just negative 30. Because that's 0. Or no, we just add... Yeah. I have it right. It's negative 30. And then the magnitude of A is equal to... That one's equal to 5. The magnitude of B is equal to... This is the one that's root 72. Which is 6 root 2. Cosine of this angle is going to be negative 30 over 30 root 2. Those are going to cancel, so it'll be negative 1 over root 2. God, I hope I'm right about the negative this time. It really is negative root 2 over 2. So, let's try this again. Negative 5 by 2 is that in radians. Arc cosine of that is equal to that. So it should be equal to 2.35 rad, which is not acute, according to our previously established 1.57 rule. Really, it's 3.6, but it doesn't matter. Let's see. I should really be doing the odds. I don't know why I'm doing the evens. That way we can actually properly check ourselves. Some of them are just kind of like, hey, figure out the answer. I'm like, okay. Yeah. Oh, that's true. We could have known the angle based off of previously already knowing the cosine. We already know the cosine of root 2 over 2's angle. Especially negative root 2 over 2, because that's just going to be in the second quadrant. So that's going to be the 45 on the left side, which is negative 3. Not negative 3. 3 pi over 4. Let me see how the audio quality is before we continue. I'd hate to get started and then like have it sound like ass like the whole time. Let me see. That's a distraction. I'm gonna put money in. I'm counting this. It's a distraction. I like it. I like it. It's not bad. It's not bad. The audio quality is not bad. I'm not gonna complain about it. All right. So here's what we were discussing earlier. Every time I get distracted, I'm gonna put fucking $20 in this shitty fucking. I don't know if it's shitty. I'm just gonna put $20 in it. Let's see. I'm doing this off screen though. Just trust that we're doing this right now. I can't show it because it's off screen, but trying to keep my financials off stream. I feel like that's ideal. Okay, I'm gonna transfer. Let's just transfer a good amount in preparation. I'm gonna send 200 from my personal account to my brokerage, and then we're gonna go ahead and divvy it up. Wait, does it send instantly? I don't think it does. I was not prepared. All right, tell you what. Here's what we'll do instead. Actually, I'm gonna cancel that. I'm gonna cancel that transfer. It's scheduled. I'm gonna delete the scheduled transfer. We're gonna keep a tally. This is why I don't draw with my mouse, because I'm not an artist. Times I fucked up. One. All right, we're at one. We're at one fuck up. We're gonna count that as a distraction. Oh, let me like this a little bit more. Okay, let's make that green because I like the color green. That's hard to read though. Let's pick a better green. I like this green. All right, there you go. Each one. So, let's continue before I stay distracted. 130, 135. We're gonna go to 135. We're just gonna do the odd ones from now on because the odd ones have the answers. Excuse me. For the following exercises, find the measure of the angle between the three-dimensional vectors. Express the answer in radians rounded to. So we want the measure of the angle. Maybe the same thing, isn't it? Okay, well, whatever. Write down our vector. 3, -1, 2. It wants it in radians still, so we're gonna maintain that. Fuck. We're gonna maintain that idea. B is 1, -1, -2. So A dot B, we're gonna have 3 plus 1, that's 4. Minus 4, that's 0. And then A's magnitude is equal to 9 plus 1 plus 4, which is 14. So root 14. Yeah. And the magnitude of B is root 6. Let's see. Is there a way to simplify that? It's 84. Two root 21. Yes. Think about it. But it's 0 anyway. Wait, we already fucking knew that. So then wait, the cosine's 0. then the angle has to either be, it has to be some sort of 90. Now, how do we know if it's 90 or negative 90? Does that matter? Find the measure of the angle. There's some information lost, thinking that it's 0. Wait, think of the magnitudes. What does the answer say? We're only gonna read the answer. I gotta zoom all the way in so I don't skip anything. We're on 135. Whoa. Angle equals pi over 2. So it was a 90. It was a 90 like I had said. But how did we know it was a negative 90 and not a 90? Does it matter? How do we get that information? Okay, that's not what I wanted. Here's what I'm gonna do. I'm gonna take a picture of this without reading any of the answers. I'm not gonna look at it. I'm gonna open the screenshot. I'm not looking at it. I'm still refusing to look at it. Oh. I'm not meaning to do that. There, that's how I pan, is I hold control. Pi over 2. We're gonna keep this in the... Oh, that's not what I meant to do. Hang on. Yeah, that's what I wanted to do. I don't want to be... I want to zoom all the way in and not look at any answers. Pi over 2. So how do we know? How do we know? How do we know that this is pi over 2? That's what I want to know. And then we'll zoom in a little bit so we can just have a little bit more visibility on the screen. Zoom out a little bit. Okay, control is not working the way it was earlier. How do I drag? It was literally just letting... Okay, now it's letting me drag. Okay, pi over 2. Let's ask Google. How do we know, using a dot product, that the angle between two vectors is pi over 2 versus, what's the other one? Because you can't have a negative 0. Pi over 2. In standard vector mathematics, you cannot distinguish between an angle of pi over 2 and 3 pi over 2 using only the dot product. This is because the dot product of two vectors is defined as that. Since the cosine and cosine orthogonal, the range of the dot product is defined from 0 to pi. Ah. I didn't know this. I feel like it might have been written somewhere. Well, at least we know now. Alright. Keeping that in mind, I'm gonna write that down. The range of the dot product is 0 to pi. Does it mention this? Whoa. Does it mention this? I guess if you think about it, No. I don't like that still. Technically, this is supposed to all be a review for me at this point in my Calc 3 experiences. When we use vectors in a more general way, let me zoom out of this. Oh yeah, I had to learn how to do vector projection again because I forgot how to do that. I'm gonna try to do it without looking it up though. Okay, 137. We're just gonna do 137. Need some water real quick. Alright. So 1, 1, 1 minus 1. 0, 1. 1, 1, 0. 0, 1 minus 1. So it's gonna be a dot product of like literally 1. A is equal to 1, 0. B is equal to 0, 1, negative 1. Is that right? Yep. So the dot product is equal to 1. The magnitude of A is equal to 2, or root 2. The magnitude of B is equal to root 2. We want the cosine. We know the cosine is 1 over 2. We know the cosine is 1 over 2. Then we know it is, and if we know the range is 0 to pi, then we know that the angle is what is it? It's I believe it's pi over 3. Let's see if we had that right. I don't know. How did I do it before? Like, not intuitive at all. Dude. How to pan in snipping tool. It's Alt Z? No. No, we just want to drag. I just... Okay, so it is control, but it just works sometimes. That's increasingly frustrating. Holding shift? Nope, that doesn't fucking do anything. Nope, that's not what I wanted to do. Now it's working. I don't know what does it. Pi over 3. That's what I said. Alright, next question. It took me way too long to do that. 139. We have A equals 3, negative 1, negative 2. B equals... Whoa, 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 whoa. What the fuck? Okay. So we have them added together, which is just going to be negative 1, negative 3, and 4. So A dot B is going to be equal to, let's see, we'll have negative 3 plus 3 is 0 minus 8. Am I right? Yeah, I'm right. So it's minus 8. Negative 8. Magnitude of A is going to be equal to... It's going to be... root 14 again. Magnitude of B is going to be equal to 16 plus 9 is 25. 26. Root 26. Since we're allowed to have a calculator for this one, judging by the T, I'm pretty sure. I have no idea what the T even means. What does the T open stack mean? Textbooks. What? The fuck is it talking about? Using technology. Okay. There's nothing like use a calculator. That's what I thought. Alright, so 14 times 26. 364. I'm trying to do as much math in my head that I can. We can break this into 182. We can divide that into 91. It'll be 2 root 91. Pretty sure 91 doesn't square evenly. Yeah. So 2 root 91. It's going to be negative 4 over root 91. Obviously, you multiply it over, so you go negative 4 over 91. Or negative 4 root 91 over 91. And then let's go ahead and, do our thing. It's 2.00 radians. Alright. Let's see what this said. I'm probably way off. What? Got it right. Look at that. It just said 2. I didn't even, put the sigdids. Or the sig figs. Doesn't even care. Whatever. 141. No breaks! Can't get distracted. Water breaks are allowed. It's not distracted. It's not a distraction. We can hide this now. We're not allowed to use it. This is not a T question. Determine whether the given vectors are orthogonal. X, Y, and negative Y, X, where X and Y are non-zero real numbers. Whether they're orthogonal, you'll have negative XY, and then you'll have XY, and those add to 0. So it is orthogonal. It is orthogonal. Because ultimately, it's going to be orthogonal if the dot product is 0, which is what this is going to say. Why does it not like me, dude? Bro, please. I'm begging you. Oh, I just have the eraser selected. Orthogonal. That's exactly what I wrote. 143. We have 3. I'm just writing the vectors at this point. I'm not writing the actual names of them. Negative 2. 'Cause I don't care about I don't care about the magnitude of them at this point. I just care about the dot product. So our dot product here is going to be -6 plus 3 is -3, which is going to be more. It's going to be different from 0. So this one is not orthogonal. $145. Find all two-dimensional vectors orthogonal to vector b equals 3, 4. Express the answer in component form. All two-dimensional vectors. That's just going to be... I mean, in 2 dimensions, it's just 3 vectors. Or 2 vectors. And it's going to be... well, we know, since we already know, we know this one is orthogonal, right? So we know -4, 3 is going to be orthogonal. And then we know that 4, -3 is going to be orthogonal. And that should be it. Whoa, that's... I'm missing something. So this is purposely left out. Okay, let's attempt this. Let's attempt this. Let's attempt this. Everything's worth an attempt, right? Let's attempt this. 145. A is supposed to be some, not some, but all orthogonal vectors. Or all two-dimensional vectors. So all 2D vectors orthogonal. I'll just write orthogonal as to b equals 3, 4. And somehow we came across -4a. Or actually, no, we decided to deduct it as alpha. -4 alpha over 3 alpha. For every real number not 0. But why? Am I supposed to imagine like a matrix here? Let's put anything in there. Let's put 1 in there. It's going to get -4 over 3, 1. Times 3, 4. It's going to be -4, 4. So that does work. What about 3? 3 is the one that we mentioned earlier. What about -3? -3 will give us 4, -3. So yeah, that works there too. So the 2 that we came up with apply to this. But how did we get one for every real number? This is when we ask AI. I love AI. Sometimes. AI is for stuff like this, where I actually don't even know what I'm supposed to do. Because I'm pretty sure that if I go through this textbook, it's not going to say what type of approach I should be making. Set the equation. Oh, that's true. Okay, it gave me a hint. Let's start with this. A, B, this has to be 0. So let's look at this Okay, this is also interesting. Then we want to say that 3x plus 4y is equal to 0. So then we just set them equal to 0, right? We find the relationship between x and y. We find that 3x is equal to negative 4y, or the opposite. So I know that x is equal to negative 4 over 3y. So whatever y is, as long as x is negative 4 over 3 times that, it should be good. Now, why does it not work for 0? Other than the fact that, you know, we can plug it in and see that it doesn't work for 0. The AI seems to think that it works for all real numbers. We're going to plug in 0 and then have it prove that it doesn't. I'm assuming that when I tell it... Oh, it does? Oh. I mean... Okay, it does work. Theoretically, it does. Geometrically, the 0 vector has no magnitude and no specific direction because it doesn't point anywhere. It doesn't violate the 90-degree requirement of other orthogonal vectors. It simply satisfies the algebraic requirement. In linear algebra, we include the 0 vector in the orthogonal component of a vector space. Okay. Not in fucking multivariable calculus for some reason, but in linear algebra we do. What a fucking concept. Like, this is just wrong then. Whatever. Alright, let's try this again. But this time we're going to get it right. Find all three-dimensional vectors orthogonal to V. So, we're going to think about what matters here. So, U is going to be in the space R3. And we need all R3 vectors that are orthogonal to V equals 1, 1, 0. Cool. So let's set this up in a similar format that we did 145. We will write down the dot product. And then we will suggest it's equal to 0. This reminds me of a lot of the techniques we used in analysis 1. Like, clearly I haven't taken, but I'm kind of self-studying it. And this reminds me a lot of some of the things that we do in there. So dot product we're going to assume is 0. We're not even going to assume that. We don't need the angle. We don't need to set this. We don't care about the angle. We care about getting all vectors orthogonal. So let's do some trickery. Let's say x, y, z dot sum 1, 1, 0 is equal to 0. Thus we can see that x plus y is equal to 0. That's all we need to know. X has to be negative y. So as long as the vector is composed in such a way where it is equal to some number alpha, negative alpha, and then z is 0, literally to any degree, we can find that it's orthogonal. I like this method. So, in conclusion, U, I don't know what they're going to use, is equal to alpha negative alpha 0. Whoa, this is alpha and beta are real numbers such that the sum of their squares is not equal to 0. Okay, I don't know this one. I'm trying to imagine it. Where did I fuck up? I don't think the such that matters. I think B can be quite literally anything. That was the conclusion I didn't reach. They're saying that beta can be what the fuck ever, doesn't matter, multiplied by 0, it's still going to produce 0. The dot product. We're going to spit this into an AI and make sure that I'm not a retard. This makes me want to do the one before it, though. Oh, no, I don't care about it, actually. Second thought. So we do it the exact same method. Y is equal to negative x, is equal to negative y. Z can be any real number since it was multiplied by 0 and disappeared from the equation. Which means we have two free choices. We can let x equals s and z equals t, where s and t are any real numbers. Then y will be equal to negative s, which is the exact same conclusion that they had reached. This is phenomenal. I love this. This is great. I'm fucking... These are some great questions. I want to do the next one. 149. Determine the real number. I wrote 146. I meant to write 147. Let's go ahead and write 147. Determine the real number alpha such that those vectors are orthogonal. So we care about A as being 2, 3, and B as being 9 alpha. We need to find the value alpha, which is a real number as stated, that will make this orthogonal. Well, let's make it an equation, right? We need the dot product to be equal to 0. So that means we need 18 plus 3 alpha to be equal to 0. Which means this needs to be, we'll subtract that over there. It's going to be 3 alpha is equal to negative 18. So alpha is going to be equal to negative 6. That's our final answer. It's negative 6. Yep. That was right. That was an easy one. That was an easy one, to be fair. 151. Consider the points P and Q. Okay. P is 4, 5. Q is 5, negative 7. Determine... I'm going to write A and B there just so that I can kind of answer them. But I'm going to do all the math under it. Determine vectors OP and OQ. Well, what is O? What is O the origin? Nothing saying I can't use the origin. I'm assuming I just do... Let me just look down the answers to make sure I have this right. It should say answers vary. Oh, wow. No, not looking. Okay, O is the origin. O is the origin. O is the origin. So OP is going to be equal to 4, 5. OQ is going to be equal to 5, negative 7. Which we already know because that's how points work. They are literally a vector from the origin. Using standard unit vectors. I didn't do that. I used components. I don't give a fuck, honestly. Determine the measure of angle O in OP in triangle OPK. Express the answer in degrees. Well, we can just do this how we did before. So we can say we're going to compare the vectors, right? So we're going to say OP dot OQ their dot product is going to be equal to 20 minus 35, which is negative 15. And then we can see that the magnitude of OP is equal to 16 plus 25. That is, we're going to have a root 41. And then we're going to take the magnitude of OQ, which is going to be equal to, we'll have 25 plus 49, which is going to be 74, so root 74. And then we're allowed to use technology for this one, so we'll pop out the calculator again. We're going to go ahead and do 41 times 74, is that? 74. We're just going to look at this real quick. We're going to see this is 30, 34. If we divide this by 2, we'll have a 15, 17. Is that right? Which, let's just see if we can divide this by stuff. 30, 34. Is this a square? It's not. We'll just run with the 30, 34 for now. So 41 times 74, we'll just say it's a cosine theta. Oh, wait, but we can do... Nope. Negative 15 over root 30, 34 over 30, 34. And then we'll say that the angle is radians. .84. Oh, in degrees. Fucking of course it wants it in degrees. Wow, now I'm fucking lost. Okay. We have this in degrees, so, or in radians, so we want to get rid of radians and get degrees, so multiply by 180 divided by pi, 105. Let's see if we had it right. Yeah, 105.8, that's what I had. Alright, next one. 153. Determine the measure of angle A in triangle ABC. That's easy. We just need vectors A, B, AC, and you compare the dot products. So AB is going to be equal to, I'm going to do 3, negative 4, negative 12, and then AC is going to be equal to negative 4, 0, negative 3, and then we're going to compare their dot product. So AB dot AC is equal to 3 times negative 4. It's negative 12. Who cares? Plus 36. So negative 12 plus 36 is 24. X cosine of the angle is going to be equal to, let's see, our AB's magnitude is 9 plus 16 plus 144, so 25 plus 144. And 175 minus 6 is 169. So it's root 169. Isn't that 13? 13 times 13. Yeah, it is. So we know this is 13. I actually don't know squares over 12, but I just remembered seeing 169 at some point. Gotta get rid of the calculator. All right. AC is 20. It's 5. And I know it's 5 because it's fucking 4 and 3, and we know that the magnitude of any 4, 3. We know 3, 4 triangles, right? I hope we know 3, 4 triangles. So 5 and 13, that's gonna make 65. So we can take the cosine of 24 over 65, or rather we need to reverse it, right? 24 over 65. God, is that really what I have to do? 24 over 65? How am I supposed to do this without a fucking calculator? I can't simplify that any further. This is really what they expected from me? Okay, well, I'm just gonna say it is the inverse cosine of 24 over 30 over 65. Because that's all I've got. Watch it give me an accurate number. Okay, it's not working again. 68.33. Let's see if we had the right numbers at least. 24 over 65. We want degrees. Oh. Could have probably mentioned multiplied by 180 over pi. $68.33. We had it right. Oh, I see. There's that little degree thing. So we want to add that to that, and then we can delete that. I'm learning about more function notations as I do this, so that's useful. I don't think we're supposed to use. It says we weren't supposed to use technology for it, but I literally wouldn't know another way to know that it's 68.33 without technology. Like, I'm gonna ask AI if there's even a way to do that, because now I'm curious, right? Where is it? Here it is. Is it possible to solve this without some sort of calculator as a human being? I am not a calculator. Practically, it's a bit of a nightmare. All right, let's get to the 24 over 65. The human wall. Okay. All right, because we could do the actual like long division to get point to get like. No, we still can't. Like, table of cosines. That's what I'm thinking. We need a table and look for the value, which is still technology. I'm looking more into how these tables were originated. Common man calculated values of trigonometric functions before the calculator, primarily using tables and slide rules. Some mathematicians were then involved in creating these tables. Methods evolved. For example, in the 7th century AD, Bhaskara produced a formula. Sine of x is approximately equal to that. Thank God we don't need to use these anymore. But I'd love to learn, like, I'd love to go through the process. This is just insanely interesting. Figure out trigonometric ratios. What people started doing was Euclid. What people started out with was Euclidean geometry. They then worked the shapes they knew something about. The first important shape was an equilateral triangle. You must first draw an equilateral triangle with Euclidean geometry. Then you can say each internal angle 60 and put the equilateral triangle inside a circle. Da, 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 da. Okay, so interesting. This is what we call distraction. This is what we call That's $40 now. It's okay. It's okay. That's actually me getting distracted. It's related. It's a distraction. As we continue. 155. For the following exercises, really quick water swig. Determine which, if any, pairs of the following vectors are orthogonal. I'm gonna do them in my head. All right. Well, let's compare them. 3 and 5 is 15. 7 and negative 3 is negative 21. So negative 6. So U and V are orthogonal. U and W are not orthogonal. V and W are orthogonal. So UVs are orthogonal. VWs are orthogonal. Okay, this adds up. Yep. All right. 157. Use vector to show that a parallelogram with equal diagonals is a rectangle. Fuck it. Just gotta draw some fucking shapes real quick. Let's reapproach the definitions of these shapes. Definitions of quadrilaterals. The proper definitions. A parallelogram is a quadrilateral. Parallelogram. I don't recall these definitions perfectly, but I know what they are essentially. And I can define them by memory while I'm working through it. But let's just take the literal definition so I cannot possibly fuck this up. A quadrilateral with two pairs of parallel sides. So that's it. We just have to have two pairs of parallel sides. And there's things we can assume from that, but more importantly, what's the difference between a rectangle and a parallelogram? Let's figure out. A rectangle, all four angles are right. So we just have to prove that in a situation where the diagonals are orthogonal or equal. I'm not looking at the answer. Does it say varies? Okay. I'm scanning. Wrong question 155. I'm scanning. I'll give you a... We're on 155. On 157. 157 is not provided. First and best AIO Kick botting web panel. Wow. Thank you, OVDN Kick, for giving me bots that I can use to my advantage. I'm not going to do that. This is just for fun. This is not for views or whatever. So we need to show that equal diagonals will produce right angles. Well, in order for it to be a right angle, we need to suggest that, let's assume this is O, let's assume this is A, let's assume this is B, let's assume this is C. We need to assume that OA dot OB is equal to 0. BO dot BC is 0. AO dot AC is 0. And CA dot CB is equal to 0. In that case, we will have a rectangle. But how does the equality of the diagonals partake in that question? What does this in particular say about OC being equal to AB? How do we get from this idea to this conclusion? Because never once do we care about OC or AB. Alright. I need a little bit of assistance. Little bit. I get what we're trying to do, but I need a little bit of assistance. Help me out. Wait, do we do the parallelogram rule? Ah. In a parallelogram, the two diagonals can be expressed as this. That's true. Okay. It's giving us a lead. Let's start with the lead and work our way. Because I don't want too much assistance. So now that we have a little bit of assistance, let's think of it this way. Let's think of this as O. Let's think of this as A. Let's think of this as B. And let's think of this as A plus B. And somehow this is going to be equal to this. Ah, I see. I think I see it, but we need to prove it. A plus B's magnitude needs to be equal the magnitude needs to be equal. So A plus B is going to be equal to it's technically B minus A. So we're assuming this. What does it say about their dot products being 0? You square both sides. Recall that a magnitude squared is equal to V dot V. I don't recall that. What do I want to recall? Give me 1 second. All right, my mom just called me, so I'm gonna head out. And you know, have some Easter time with them. So you guys have a good one. I'm glad you guys could stick by. I'm gonna do some more studying later. Y'all have a good night.